Hello, so this is the brief intro to the lab equipment that's used in the Power Electronics Lab at CSU, so that's FH37. So this will apply to EEC 471, Power Electronics 1. It'll also apply to Power Electronics 2 and the Electric Machines Lab. So this is one of the lab benches we have here, plugged into the wall. They get a two-phase supply, and they will spit out three-phase voltage source here. So you got a power supply unit in the bottom right. Each one comes with a low power supply that's located down here that supplies 24 volts DC to various pieces of lab equipment on the bench. So there's a little gray cable, looks a little something like this, has a little pigtail connector right here. So you can run that cable from one of these ports here to, let's say for example, a power meter, or it could also be a MOSFET or a thyristor as well. You're not going to use this in the intro labs, just something so you know, because once you hit labs about 4 or 5, you'll start using it. This also controls the voltmeter display that is built into the bench. This does look a little different on some of the other benches. I'm just using this bench for here. The other benches have a analog meter, but all of them function the same. So this switch here controls the main power, which is connected to these larger ports up here. The port right here always outputs 120 volts AC. The ports 4, 5, and 6 supply variable 120 volt AC. So you can control the voltage using this knob, and we'll set the voltage to anywhere from 0 volts to 120 volts. The ports on the rightmost side here are DC, so it's 0 to 120 volts variable DC, and this is just a set 120 volt DC. This is all intro. You might not be using this in this first lab. So in exercise 1 of the first lab, you have to build a circuit where you take a 3-phase voltage supply, 120, and you supply it to a resistor network up here. I'm going to quickly grab the lab manual here. So you have this is a Y-connected circuit. So in order to do that, it's as simple as it would be on a breadboard, but it's way easier because it's just like clipping stuff in. So in the manual, you'll see a supply is shown a little something like this. You got a sinusoidal source, and you see L1, L2, and L3. So this is not the norm. This lab, unfortunately, uses different notation than the rest of them. So in future labs, it'll note it as like 1, 2, or 3, 4, 5, and 6. But regardless, in this lab, since it says L1, L2, L3, and it shows it as a set 120 volt source, so there's no arrow through there that shows that it's a variable source. Sample of a variable source is also not in this lab. So future labs, you'll see this same symbol right here. It'll just have an arrow pointing this way that indicates that it's a variable source. So anyways, you got your source here, and we're going to run it to resistors. So line 1 is running to this resistor here, line 2 is running to this resistor in the middle, and line 3 is running to this resistor over here. Each one of these is like a separate channel. They're fully isolated, and there's 3 resistors in parallel. In order to turn a resistor on, you simply flip the switch up, and it'll add that resistor. On the side of your bench, there's a key that indicates that will take care of the resistor translation for you. So at the bottom of the page here, you'll notice it says, for 120 volts, 60 hertz input, which this is always what we are using in this lab. Always look at the 120, 60 hertz local AC power. So that's what's coming out of the wall in here. That's just assumed, and that is constant for all of the labs taught in this lab at Cleveland State. If it says R1 is 300 ohms, what you'll do, you'll go to the side of the bench, and there's a little table, and you'll see 300 ohms, and it'll tell you what switches need to be on and which ones need to be off. If it is a dash, it needs to be on. If there's nothing there, it needs to be off. You'll also notice that sometimes there are more dashes than just 3. That means you'll need to connect all of these in parallel to lower the resistance. So that would mean you have to short both ends of these resistors together. Obviously, this circuit is 300 ohms, so all you're going to do is flip the switch up 300 ohms for each of them. And since it's a Y-connected circuit, all of these resistors will be terminated into a common connection here. It wants a neutral return, so I'm going to add that. So I'm going to grab a blue cable from the side of the bench, one blue cable, and hook it up to any one of these because they're all shorted together. It's just a wire, just like a node, and you'll run it down to the neutral down here. So now the circuit's completely connected, but as you notice, the power switch is not on. So this is a breaker, but whenever you're plugging things, make sure you do not have the main power on. As soon as you turn the main power on, these little lights will turn on green. So we're going to watch that happen as I throw the switch. It will turn on green. If I want to see what voltage is coming out of these ports, in this case, I'm going to move over to 4, 5, and 6 just so you can see how the variable voltage meter works. So 4, 5, and 6. This little knob allows you to select what's shown on the display. So for example, let's say you want to look at the voltage measured from 4 to neutral. So that's going to be your line to neutral or phase voltage. It's set for 4 to neutral, and I'm just going to turn this knob, and you'll watch as the voltage increases. If I want to measure the line-to-line voltage, I could turn it to 4 to 5, and I can measure the voltage between lines 4 and 5. These are 2 different measurements, so rather than having to calculate them like you would normally, this actually takes care of it for you. That's the same on all of them. All of them have the selector switch. They're just kind of at different positions. First you're going to want to measure the voltages. So there's 2 different Fluke meters in this lab. We have one that's a Fluke 177. We just got more of them. So you should have 1 or 2 per bench. So with these meters, you can measure different measurements. So you can do AC voltage, DC voltage. You can do millivolts, which is not relevant for this class. You can measure capacitance and resistance. That's just a continuity check, and then you can also measure current. One thing to note is that if you don't get a current measurement, it likely means the fuse is blown in here. I do not recommend ever measuring current with these because 95% of the time the fuse is blown in this meter. I would recommend getting one of the DC voltmeter or ammeters from the wall. Looks a little something like this. On the wall racks, not out of the wall receptacles. Grab one of these, and those are the most reliable current measurements. No, they're not digital, but they're way more accurate. So in this case, we need to measure the voltage across R1. So I'm going to show you how to do it.
Note from the cameraman, if you're trying to measure voltage, make sure the probes are connected to the voltage on the Fluke. If you're trying to measure current, make sure the probes are connected to the current on the Fluke at the bottom there of the meter. If they are flipped, you can blow the fuse and then your Fluke will no longer work.
So after that being said, first thing I'm going to do, both are connected to the voltage, so it's V to COM. So I'm going to take this voltmeter here, I'm going to turn the light on just so you guys might be able to see the changing voltage as I plug in. So, got power, I'm going to turn the knob to ramp up the voltage. So I want to measure the voltage across this resistor. I can simply take the 2 probes and plug them in. And I'm getting no voltage, and that might be because I have it set for DC. So if I change to AC, I now will measure 58 volts. Now, as you notice, I had to kind of move the probes around to get a reliable voltage reading. It is always in your best interest to actually make a permanent connection with these probes. These probes are safe to plug directly into the meter. So you can just run this probe here into here, and you can run this probe here. And we can actually just run this down to neutral, because this is a common node with what's here, got a wire running from neutral here, and that's connected to the other terminal resistor. So you can see I have a nice steady 57 volts measured here. If this is a nice balanced circuit, which it should be, you expect to get this across all the other resistors. I'm not going to demonstrate that right now. To measure the current, as you should know, all you need to do is put a break in the line. So for example, we're going to measure the current flowing to this resistor. So we're going to take this, we're going to plug this into the 2.5 amp slot here. The amperage readings there just indicate what the rating is. If you're over that rating, you could damage the meter, so just be careful or which one you're plugging it into. Now, since we're trying to measure positive current flow, you'll always plug the input into the red port and the output into the black port, indicated by the negative. So I'm going to drop this in here, and you will see that a current should appear on the meter, if I have it on the right one. It might help if I actually increase.
Well, that's a DC. It's looking for a DC current on that
Oh,
meter. That's
I don't have
why.
AC meter. Yeah, sorry.
Yeah.
Okay.
So there is a AC module that we can use to do that.
Let
But
me
we won't
quickly
do that
release
in
it.
this video.
Yeah, let me quickly grab the AC module for you. I should have thought of that. So you can see from my mistake, it's very easy to forget that which one you're working with, so just be prepared for that. You're right. I'm not going to grab the module right now, just
Yeah, we
because it's too
don't
long
need
to
to
solve
I
now.
can show them that.
Last thing I want to show you how to use is the voltage isolator, just so you can see waveforms on the display here. Actually, we can measure, one thing I should probably show is that we can measure current on these meters. So these only work for AC. This is a power analysis, power quality analyzer fluke meter. So we have this current probe. For those who aren't familiar with them, clamp them around the wire. So in this case, we're going to clamp it around this blue wire that's supplying. And we're going to put it in the volts, amps, hertz mode. So you'll hit enter. I need to restart this meter.
Well, it's restarting. Why don't you set up a voltage measurement with that too? No
Yeah,
reason
I'm
not to.
trying to.
There we
So,
go.
unfortunately, so on the meter, if I can bring it if I could bring it closer, you'll see there's actually a small current appearing on the screen, and you'll also be able to see the waveform of the current. It is not as accurate as a scope, but it is there. If you want to measure voltage, there's a red port. You plug that in here, and you'll run this over to one resistor, and we'll take another. We'll take a yellow probe in this case for ground, and we'll run it in here to neutral. So now we're measuring across the resistor. As you might be able to see, a sinusoid appears on there, so you can see the waveform of your voltage. You can see that we're supplying 117.3 volts AC. That's your RMS voltage. And this is your line to neutral voltage. So be very careful when you're taking this that you are measuring exactly what you intend. If you're measuring phase voltage, reference it to the neutral. If you want line voltage, make sure you're referencing it to the appropriate line. Regardless, there's a waveform and a frequency display. Now, what's really cool is you can also take power measurements right from here, not having to mess with these giant meters. In some labs, if it's showing you how to hook up these meters, always just use these ones. It's simpler. If it doesn't show you how to hook it up, always try to use this, just because this is what you actually use in the field if you go into the field of power electronics. So, shown here, you can see the voltage and current waveforms. You can also see the real power, the reactive power, and your total apparent power as well. The power factor is shown, You can also view the harmonics of each of your current waveforms if you're working with switching converters. So these are very powerful tools. I'll have some future YouTube videos on how to view those. So that's one way to view different setups. Now, what you want to measure is actually you want to be able to see the waveform of your current or voltage. So that's where this unit comes in. Each of you should have these little plug-in units. They just screw in and plug in. So if you don't have a voltage isolator, just ask your TA, and he or she'll be able to provide it. So how this works, this isolates your scope from your unit. So you can supply 300 volts to this thing, and this will only see somewhere between 0 to 10 volts. So first step is to turn on your scope. Most of them don't have actual power buttons, so if your pinky's small enough like mine, you can probably fit it in and try to push it down. If not, use a pencil. I didn't advertise using your pinky to push that in, so just be careful. You can get stuck, or I don't know if there's any electronics in there, so just be careful.
Enough to wake you up at least. Also, yeah, please don't put 300 volts directly on the Tektronix. They don't like that. They start smoking.
So once it comes up, you should be able to see your data, or well, at least see a normal scope plot that most students should be familiar with. So be very careful when you set this up that you don't accidentally put it in the wrong language. It's currently in French.
Oh gosh, that definitely happened this morning.
So ignore the fact that it's in French, and we're going to focus on just hooking this up. So this isolator, first is if you want to view your volts, you're going to plug into the E, or voltage isolator. And in order to view the voltage waveform, you'll need to take your probes that you're using over here and move it over here. So your positive goes up to the red probe, and I'm going to need a blue wire for that, so give me 1 second.
While he's doing that, quick safety note. Caleb's been doing this for years, so he goes ahead and handles the probes directly while the power's on. We would like you guys to turn the main switch off before you start moving any wires, just to make sure no one gets hurt by the bench.
Yeah, I'm setting a bad example, sorry.
You're good. Pretty high voltages, you can get stuck to the bench. We don't want that. Then we have to, get you unstuck from the bench.
So when I plug this in, you'll be able to start seeing a voltage waveform here on the scope. And the important thing is, if you want to actually come over just to zoom in, so we'll just, no, actually, okay.
I can zoom in.
So let me know when they can see the waveform.
Oh, okay, yeah.
You're probably going to want to come closer.
Yeah, I'll go ahead and do that just so the reception's a little better.
Okay, so first thing you're going to want to do, you can see the yellow is moving across. So in order to look at the settings for channel 1, you're going to put this as channel 1. So now you can see the settings here. So I know what all these settings are, even though they're in French. So the first one is going to be your coupling settings. So I'm actually going to change this into English really fast. So that's going to be the utility menu.
You don't want to leave it as couplage?
Language, we're going to put to English. It really likes French.
You can leave it in Spanish, that's good too.
Oh my gosh. Okay, we're in English. So if we go here, so DC coupling in this case, that just, I'm not gonna try to explain that right now. Your probe right now is at 1x. Always be sure that it's 1x. These BNC cables that plug into, this is a BNC cable here. These must be put as a 1x probe scale. Most normal probes that you plug into an oscilloscope are 10x probes. These are 1x, so be very careful about that. Otherwise, the measurements you're getting off of here are wrong. So, in order to make this so that you got a nice stable waveform, we need to adjust the trigger. So we're gonna hit trigger menu, and we're gonna change the source to channel 1, and edge trigger. So now you can see we've got a nice stable waveform, and I can adjust the amplitude using the using the vertical scale, shift it left to right, or up and down here, and then left to right using the horizontal menu on the left. This adjusts your horizontal scale. So I'm going to zoom in. Okay, so you can see the nice voltage waveform. So if you want to measure, so this is one way to look at a voltage waveform, is to use the isolator built into your bench. There is another way that I'm going to demonstrate in one moment, but just for your information, if you want to set up some measurements on your scope, you're going to hit the measure button. And so now you can set up different measurements for your channel. So you change your source to channel 1. Peak-to-peak voltage is shown as 11.5 volts. Okay, so we know that's not the case. We know it's around 117 volts based on the measurement we took earlier. So how you scale that is, if you look on the display here, it says 0 to 10 volts here, and this is 0 to 300 volts. So your ratio is 300 over 10. So 1 volt on this equals 30 volts in reality. Now, you need to be careful what your voltage scales are in the graph and stuff. So if this is 11.5 volts, this is suggesting that we have, oh, this is peak-to-peak voltage. This is not RMS. So RMS is 3.96 volts. So that would be 3.96 times 30, which would be approximately 117 volts. I'm not going to go back and do the math, but 3.9 times 30 is roughly 117. So the other way to get a voltage waveform on here is to use you can just stay there, don't move, is to use one of these high voltage isolators. These are very common in the field. I have one of these at work. They can isolate very, very high voltages compared to these. This is good up to 1,000 volts. They look a little something like this. These can plug directly into wherever you want to measure. So if you want to measure across this resistor here, boom, boom, you're now measuring across that resistor there. This end here, there's this little black intermediate piece. This needs to be have a wall adapter plugged into it, and then this will plug into the wall. That's a power supply for this unit. The other step is to plug the BNC connector here into your scope. This will display the exact same as this, just with the voltage isolator, just with different scaling. The guide to the scaling is on the front of this probe. If you have any questions about how to use these, if you decide to use it, talk to your TA to work out the scaling factor. So that should take care of the rough intro of how to use the lab equipment here in the Power Electronics lab. If you have